Hey everyone, and welcome back to my channel. Today, we're going to be talking about factoring expressions that follow a cubed plus b cubed, or a cubed minus b cubed. So let's start with a cubed plus b cubed. A and b can be any terms that we want. They can be expressed in terms of reals, in terms of x, y, whatever variables. The only important thing is that we have the ability to cube them, and therefore cube root them and get a real result. So they're going to factor to a plus b, and then a squared minus ab plus b squared. It's a very similar result for a cubed minus b cubed, where we're going to get a minus b, a squared plus ab plus b squared. So let's get into some problem solving. Okay, so we're going to start off with the following two examples. So let's take the one on the left to start. So in solving these types of factoring problems, the first thing is to ask what a and b are. So you might remember that if we have a cubed plus b cubed, our expression is valid. So in this case, we could say that a cubed is equal to x cubed. We take the cube root of both sides, and that tells us that a has to equal x. And 1 can be b cubed. If we take the cube root of both sides, we just get that 1 is equal to b. So now to factor a cubed plus b cubed, remember that it's equal to, we have a plus b, a squared minus ab plus b squared. So in this case, we're going to get x cubed plus 1 is equal to, and now we just plug in our variables. So x plus 1, x squared minus x times 1, which is just x, and then we have plus 1 there. So as an exercise, what we could do is we can expand this to see if we get the same result. So expanding it means that we're going to distribute to every term. So that's going to be x cubed minus x squared plus x squared minus x plus 1. Okay, now our x squareds and x cancels, which leaves you with x cubed plus 1. So now we know that that factoring method does work for that term. Okay, so moving on to the right side, it's the same thing. We're going to look for a cubed plus b cubed. And this is a more complex example because we have variables that are working with multiple different types of things, right? We have x's and y's on the left term, and we have z's and x's on the right term. So how we're going to do this is we'll say that a cubed is equal to x cubed y to the power of 6. And we still take the cube root of both sides, right? So that gives me a is equal to x y squared. For cube rooting, if ever you're lost, remember that you can pretty much just take the exponent up top and divide it by 3, and that's going to give you the results. Now for b cubed is equal to z cubed x to the power of 9. We take the cube root of both sides, which gives me that b is equal to z times x cubed. So following the same pattern that we have on the left there, we get that x cubed y to the 6th plus z cubed x to the 9th is equal to, and we have a plus b, so that's xy squared plus zx cubed. Now we're going to have, and this is where it probably comes in handy to have multiple smaller brackets, so xy squared squared minus a times b, so that's going to be xy squared zx cubed, and we'll have plus zx cubed squared at the end there. Or when we simplify this, x cubed y to the 6th plus z cubed x to the 9th is equal to xy squared plus zx cubed. X times y squared is going to be x squared y to the 4th minus, and then we're going to get x to the 4th y squared z plus, that's going to be z squared x to the 6th right there. So as a final answer, we get that as the factored form of x cubed y to the 6th plus z cubed x to the 9th. Okay, so we'll follow it up with these two examples that are on screen here. So in this case, we're going to have, remember we're looking for a cubed plus b cubed. So a cubed is going to equal 8x cubed. I take the cube root of both sides, which gives me 2x, right? 2 is the cube root of 8. And for b cubed, I would get 27y to the power of 6. That's going to give me that b is equal to 3y squared. So remembering that a cubed plus b cubed has to follow a plus b, a squared minus ab plus b squared. I'm going to get that 8x cubed plus 27y to the power of 6 is equal to 2x plus 3y squared. And good idea to get the big brackets at this point. So 2x squared minus 2x 3y squared plus 3y squared, and that's going to be squared as well. Okay, so that's going to give me that 8x cubed plus 27y to the power of 6 is equal to 2x plus 3y squared, and that's going to give me 4x to the power of 2 minus 6xy squared plus 9y to the power of 4 as the factored form. Okay, so with that example right beside us, I'll get you to go ahead and try the example on the right. We have 64z to the power of 6 plus 8w cubed. So go ahead and pause the video and come back here when you're ready for the solution. All right, so same principle as before. I'm going to try to take up a little bit less space this time if possible. So we have a cubed is equal to 64z to the power of 6. We take the cube root of both sides, which is going to give me that a is equal to 4z squared. And now we have b cubed is equal to 8w cubed. I take the cube root of both sides. That gives me b is equal to 2w. So same expression as what is right there. So we're going to have 4z squared plus 2w. And at this point, it's a good idea to pull out the brackets. So I'm going to get 4z squared squared minus 4z squared 2w plus 2w squared. So that's going to be equal to 4z squared plus 2w. And we're going to multiply that by 16z to the fourth minus 8w z squared plus 4w squared. Sorry, that squared should be on the 2w there. So just like that, we have developed the factored form expression for 64z to the power of 6 plus 8w cubed. Okay, so now we're going to change it up a little bit from what we were doing before. We're going to work with the minus side, but you're going to see that the math works the exact same in this example here. So we have x to the power of 6 minus 8y to the power of 6. And remember that we're looking for a cubed minus b cubed here. So first thing that we're going to do, just like last time, right? We look for a and b. So a cubed here can be equal to x to the power of 6. We take the cube root of both sides, and that's going to give me a is equal to x squared. Now for b, we have b cubed is equal to 8y to the power of 6. Cube root that, and we get 2y squared. Now, as was written earlier in the video, we have that a cubed minus b cubed is equal to a minus b, a squared plus ab plus b squared. Okay, so in this case, I have x to the 6th minus 8y to the 6th, which is going to give me x squared minus 2y squared. And that's going to be x squared squared plus x squared 2y squared plus 2y squared squared. So I'm going to simplify everything in there. That gives me x squared minus 2y squared. X squared, we're going to square that, which is going to be x to the power of 4. plus x squared times 2y squared, which is 2x squared y squared, plus 2y squared squared, which gives me 4y to the power of 4. Okay, so now that we've done that example, I will get you to go ahead and try the one on the right. So we have w cubed x cubed minus 125 w cubed q to the power of 9. So go ahead and pause the video and come back here when you're ready. All right, so we're going to start with a. So a cubed is w cubed x cubed, which gives me that a is equal to wx. And we're going to have that b cubed is 125 w cubed q to the power of 9. That's going to give you that b is 5w q cubed. Okay, so using the same expression that we have on the left there, we're going to get that it factors to wx plus 5w q cubed. Then we're going to get wx squared plus, sorry, that should be a minus sign in there, plus wx 5wq cubed plus 5wq cubed squared. Okay, so that's going to give me wx minus 5wq cubed, w squared x squared plus 5, and this is where it gets a bit complicated, so just break it down, take it one variable at a time, right? Q cubed w squared x plus 25 w squared q to the power of 6. So that is the expression that you should get for the factored form of w cubed x cubed minus 125 w cubed q to the power of 9. Okay, so that's it for me right now. Thank you very much for your attention, and I hope that you learned something valuable.